All right, so this is problem number 7. This is going to be a sample standard deviation or sigma unknown. So again, notice they went ahead and they gave you the setup. So this is going to be a two-tailed test. Well, your two sample data is down below, but notice they do say sample standard deviation, not sigma. So again, they're going to be using 0.05 significance level. Remember, you have to now go to your t-table to look this up. So you might say, well, what value am I going to be using in my t-table? Well, the formula that you will use for your degree of freedom, let me just write this out. All right, so for your degree of freedom, it's going to be N1 plus N2 minus 2. So you just simply take your two sample sizes. So in the first one, it's going to be 10, and then your second one is going to be 8. So 10 plus 8 is 18. Minus 2 would give you 16. So using degree of freedom of 16, this is how you do it for two samples. And then, of course, it's a two-tailed test using that alpha level of 0.05. When you go to your t-distribution table, you should be able to find 2.12. And let me just show you real quick so you see that. So let me get my table pulled up. So remember, this is a two-tailed test. So at 0.05, you would go down to degree of freedom of, what do we say, 16. And you'll notice there's your number right there. That's where they get the 2.12. So again, that should be reviewed. It's just how you calculate the degree of freedom is a little bit different. All right, so other than that, so once you get your decision rule, so then you've got to, they want you to calculate, you have to do this thing called a pooled population variance. This is simply where you're averaging your standard deviations. So the way you do that's right here. So you got to use this formula right here. In fact, this part, whatever number you get here is going to be part of your test stat formula. But here's your formula where you take your n minus 1, square the standard deviations, you put that in the numerator. Notice there's your denominator, simply your degrees of freedom. They get what they call your pooled variance. This number is going to be the number you're going to use to calculate your test stat. That's the number you're going to use down here when you do that part. So notice your formula for your test stat is a little bit different than what you use for sigma known. But once you use this formula, once you get a test stat, the way you calculate your rejection or do not reject the null rules is essentially the same. But just again, this is your pooled variance formula. Get used to it. And then whatever number you get here, you plug it in to your formula, and then that's how you get your test stat. So I think at that point, they came up with a negative 1.41, and then of course, you have your rejection rules, do not reject. Now in this case, the p-value, they want you to go into your t-table and look it up. They give you a range of p-values. So you'll use that test stat, which is use the absolute value 1.416 to see where that falls in your table. And at 16 degrees of freedom, it's going to fall between 0.1 and 0.2. And again, let me show you that if you're wondering what I'm talking about. So again, where we're at here is we're at the row 16 degrees of freedom, looking for 1.416. It falls between these two numbers right here. So that's between 0.2 and 0.1. So there's where they get that range. So that's how they do that. All right. So that is all I have on this one. That is problem number 7. So let's do another one. It's going to be the same thing. Just look for sample standard deviation, which is right here. So we know this is sigma unknown. They give you, it's a two-tailed test. In this case, a significance level of 0.1. You should be able to use that and the new formula for degrees of freedom to be able to find that 1.697 in your table. Okay, and so once you get that, then of course you do your test stat calculation. Again, let me show you the two things you got to do for that. You got to do a pooled variance, which is right here, and then this number gets plugged into your test stat formula, and then that's how they get the test stat. You compare that to your critical values. In this case, you're going to say do not reject. So again, in this problem, it was 30 degrees of freedom, N1 plus N2 minus 2. And of course, they get a p-value. It's going to be the same as the previous one, it looks like, between 0.1 and 0.2. All right, so this is another practice one very similar to number 7. All right, number 9. On this particular one, it's going to be a one-tail test. And the key here, it's an upper tail because they want to see if one is spinning more, that's a greater than. So most likely this will be the alternate, will be a greater than. And it's a one-tail test. And again, you've got to plug your degrees of freedom in to get your decision rule. You should be able to find 2.485 using, again, degrees of freedom of N1 plus N2 minus 2. They're using 0.01 significance level. And then let me page down and again show you the formula for test stat. Again, here you go again. Plug it in, get your pooled variance, and then plug this number in to your denominator to get your test stat, and they got 1.949. All right, on this one, I'll help you out if you get stuck with it. They, for some reason, want you to use a calculator. If you want to use, an Excel formula, that's fine, but they got the p-value of 0.0313. But again, your decision rule here is going to be do not reject. All right, so last one, number 10. On this one, what they do is they give you 2 samples. They don't give you anything else. They don't give you the sample standard deviation, so you have to manually calculate this one. I'm going to let you do this. If you need some help, let me know. But you have to calculate the sample standard deviation for each of these 2. That's why they give you the data file. But everything else is the same. It's 0.1 significance level. You should be able to find this this critical value, this T number in your T table. And then of course, let me go down, I'll show you the formulas for your pooled variance, which is 204.08. And then you plug that right here. I don't know why they took that out 3 decimals, but 2 decimals is usually good enough. There's your test stat, and then you can compare that with your T value from your T table. And then the p-value in this problem is going to be 0.0763 once you figure that out. All right, so at that point, and of course you'll say when you go to your table, I like that they just say you give it a range, because usually, when you're using tables, you can't get exact p-values. So there would be your range of p-values. All righty. And so other than that, I think that's it on my comments for chapter 11.